Hi everyone, I'm Krzysiek. Hi. Hey. I'm a fan of LeSS and fan of non-violent multi-team product development. Um, since the conference is titled Talk Less, I decided to do something and I will draw. And as you know, every good agile presentation has to have an iceberg model, so I prepared mine. Here it is. Ta-da. Uh, can you help me? Okay, so moreover, I decided that I'm gonna talk less about less today. Instead, I would like to take you on a journey through basics of systems thinking and show you how powerful it is, especially for elevating the understanding, the level of knowledge and understanding what is really going on in the organization, and then find like better leverage for implementing change. Okay, how many of you finds improving organization tiresome, hard work? Oh, nice. Good you're here because systems thinking makes things easier or at least more transparent. Okay, thank you. Yeah, could be. could be on this side. Thank you. Oh yeah, that could be there. Is it okay for the camera? And for you? Okay, we live in the world of events. Yeah, we are event-based, event-driven creatures. You know, back on production, scope delivered, new customer joined, few customers left, missed deadline, and so on. And we're no surprise, someone may say, because we evolved, our brain evolved to notice events and react on events quickly in order to survive. And in the organizational context, the consequence of that is that actually we are judged through the prism of how effective are we in dealing with events. For example, if there is a bug on production and somebody will remove this bug, save the day, we call it even efficiency. So somebody efficiently removed the problem, he is appreciated. Efficient manager is promoted. So higher the hierarchy, more demand for being efficient. Quick fixes, quick solutions, this is what we are expected to do. So we may say CEO mostly firefights with all the problems, events, and so on. So that's the level we see. Oh, let me just use it. Events. But it doesn't sound, I mean, it sounds like very reactive behavior. So there's an event, there's a reaction. And how about to switch a bit toward more strategic thinking? How can we like say that more events like this coming, more bugs are coming? Are we in good shape? I mean, in terms of whatever metrics like maybe speed or adaptiveness or something else, quality. So how can we notice that? If we have enough events, what we can do with those? What is it? I mean, yeah, we try things and then we have some events, we notice events, but we can't see some kind of a trends. But if we use even a simple tool like this paper sheet, we can organize this into some kind of a trend. So we see something reinforces up or down or oscillating. So we can say we observe some kind of a behavior. So we recognize some patterns. There are cycles and it looks like there are some patterns. So the obvious question is what drives this? What makes this behavior? What causes this behavior? Is there any invisible force underneath somewhere? And if you think about this for a second, if this was what would possible to understand, to visualize the force that causes this behavior, that maybe we can understand this force and influence this force, or recreate or create our own force in order to create anticipated behavior, and then get rid of all those not needed events and create trends and behavior results that we really need and want. So, is there any possibility to visualize this hidden force? And that's the beginning of systems thinking. So, systems thinking consists of two words: thinking, and I believe you know what is it, and systems. So let's go. Assumption. Okay. So let's go through the definition of system. System is a set of interrelated elements. So we could say, well, so there are some elements interrelated. So, and it's very important. It's not like a collection of items. It's elements and interrelations that influence each other. So they form some kind of a structure. We call it structure. And what's more important, elements organized in a specific way to serve a particular function or seek a particular goal. So on the very bottom, we could say every system has a purpose. So we could say it's designed to serve a particular function. For example, engine in your car is a set of elements combined to serve a particular function. If you remove, those elements are organized in a specific way. If you remove one of the parts from the engine will stop serving particular function. Yeah. And what is interesting, every system is a part of a bigger system. For example, engine is a part of a car. Multiple car could be organized in some other system like racing or I don't know, traffic. Traffic is the side effect of some other bigger system, social systems, and so on. So there is a particular goal or particular function. But well, Chris, if you ask somebody, if in the context of organizational design, if you ask 5 different persons, if you tell them that's the purpose of the organization, could you come up with some idea for how to organize stuff? Then I bet those 5 people with the same task will come up with 5 different ideas. Why is that? Maybe 10, maybe, what is it? Yeah, and that's the missing piece of this iceberg model. So the problem is that we are people, and it's done by people. So this level, it's called mental models, beliefs, values, biases. So we could put it in reversed way. In order to fulfill a purpose through mental models and beliefs and values and biases, we try to influence or create the system that will generate some anticipated behavior that we can see in the form of events. But where's the systems thinking, Chris? So, systems thinking is something that help us. You could call it it's a toolbox. It's a set of tools that helps. It's a way of seeing and talking about reality. And very important thing is we try to visualize things. And talking is crucial thing, and we don't do it by ourselves individually. We gather people with different points of view, and then we have this conversation and try to understand what is really going on, challenge mental models, and visualize stuff. And then if we know this, or have elevate the understanding of this reality, we may find like, higher leverage on how to influence the system. If we can do it, then maybe we can create anticipated behavior and then events. Okay, so I will show you two tools from systems thinking, and one you already know. I will draw it here. One very common and useful tool is called behavior over time. So you may take an element or variable of the system, some element you measure, for example, velocity in time, and then if you ask somebody or the group, so how the velocity behaves, you may find like, oh, well, sometimes goes up, sometimes down, up, down, and so on. It maybe goes like this. And then you could use different type of color, sometimes very useful in this exercise. And then on the different axes, let's find out, for example, number of bugs we have. Is there any correlation? So maybe you could find like, okay, so bugs actually behave very kind of differently, but it's like a kind of like pattern. Maybe we have some kind of a correlation, but still we don't see the structure and this invisible force. But actually we can observe something and start the discussion. So, okay, how about to visualize what drives this behavior? So the second tool, some of you already know this, it's called Causal Loop Diagram. And because I already mentioned velocity, I will use it as an example. So, is it visible? So, okay. So, velocity. So we say velocity sometimes goes up and down. For example, if this goes down, what do you think would be the... oh yeah, one thing for you to understand this causal loop diagram, I forgot to mention. You just, to start modeling, it's not model important, but modeling, so discussing with people, you need to know three things. One, the model will consist of elements, sometimes called variables, like velocity, number of bugs, percentage of something, level of something, velocity, and so on, probability, something that may change a state. And then you connect those variables using two types of connections. One is direct, so two elements connected with direct link will behave similarly. So, for example, if the velocity goes up and connected variable is probability to be on time, so if the velocity goes up and it's quite high, then the probability to deliver scope on time is also high or down? Of course, full of... that's your mental model, or mine. So, I mean, the example was to show you that those two connected variables, they may both go up or down. If velocity is too low or going low, then probability of delivering the scope on time will also go down. The second connection is opposite, and this little circle means O, opposite, means if one variable goes up, then the connected variable goes down, or if this goes down, the second connected goes up. For example, if number of bugs go up, then the velocity may go down. I know it's the story of context, needs some context, but it might be like this. So if the number of velocity goes up, number of bugs goes up, velocity goes down. If number of bugs goes down, velocity goes up. Two different connections and variables. First variable in my so how it works, how to visualize structure, the force and the system. First is the first element, velocity. If velocity goes down and you think like, well, we're not going to do it. We're gonna miss the deadline. So what would be your immediate reaction? Yours or your boss's? Shift the deadline, of course. We can't shift the deadline. You know, the marketing already sold that, and salespeople sold that already to our customers. We promised, change it or change it. So the quick fix might be, for example, to elevate pressure to improve velocity. So it works like this. If the velocity goes down, pressure goes to improve velocity goes up. So that's the opposite connection. And if the pressure goes up, we believe that this will improve velocity. So that's why, and sometimes works like this, right? And we visualize this on this behavior over time chart. So we added a little of pressure, then we improved the velocity. Then the velocity went up, so we may start adding less pressure. And then, so the velocity started behaving like this. But why the hell this goes down after some time? So this loop, sometimes you can call it as a balancing loop, B1, and explain into some notes what is it, what is happening here. But that is the simple example of the system. Two variables and stabilization. So this homeostasis effect, right? But can we add more elements to this system? If you add pressure to improve velocity, what may happen? Yeah, and then you go to the person who come up with this solution and say, what do you mean by adding pressure? Like having a stick above the developers? Oh, no, we need to plan more, focus more. But what do you mean by focus more? We are extremely focused. Oh, well, don't build a beautiful code. If this works, if the code works, don't refactor that much. We don't have, luxury of time and just, make shit done and so on. Okay, so actually we focus a bit less. Of course, quality is very important, but we shift focus toward completing things. So we decrease focus on clean code and good design a little bit. It's not a problem, Chris, right? So, okay, over time. So it means like this. We add the pressure to improve velocity, then actually we gain this velocity through having less focus on clean code and good design. So higher pressure makes the clean code and good design lower. Of course. Thank you. Opposite. So if the level of clean code goes down, means we have messy code. If we have messy code, for example, first of all, I need one, let's put it like this. A's, to speed up, A's of implementation. So if level of clean code is quite low, so messy code, so A's of implementation, how easy it is now to read the code, find out what it does, and make changes, goes down. If this goes down, then velocity it goes down because now the duration for the task, average cycle time, you could say, it's longer, it's more effort needed. Also, the thing you just said, well, doesn't stick. Yeah, I just lost my mental model. Less clean code, maybe you have more bugs. If you have more bugs, maybe the velocity goes down and so on. But the problem is that we can't see it because we added the pressure and we don't see immediate response. There is no event. The only thing we see, we improve the scenarios. So we believe adding pressure, velocity will be improved. The problem is because then we lost a little bit of focus on this, and then we have a little bit less clean code, and maybe this will reinforce and impact negatively velocity. So we add more pressure and even less focus, and more pressure and less focus. So over time, you will have less and less clean code. And to emphasize this delayed effect, we use those two parallel lines, delay. So actually, it's like how to boil the frog problem, yeah? So over time, there are some unintended consequences. That was a very good intended quick fix, right? And improved stuff. But actually, over time, this system impacts negatively this very important variable that we wanted to improve on the very beginning. So we could say over time, the level of technical debt, for example, or the level of clean code goes down, meaning it will make the velocity be lower and lower and lower over time. So if you can see this, discuss this, then you can maybe find better ways, higher leverage, how to improve the system. So maybe instead of pushing for more velocity that will reinforce this velocity down, maybe you could stop for a second, invest in clean code, automation, and so on, and then regain velocity and reinforce velocity to the different way, not down but up, and so on. And we could, of course, add more and more variables, more scenarios, and discuss the impact of this or other elements on morale of our employees, turnover rate, and so on and so forth. But I hope you get an idea how it works. And, well, you need to start doing, as Jürgen said, do this, and instead of talk about this. Okay, so, and that's the superpower. This systems thinking is a superpower of seeing the whole. So you learn how to see a bigger picture and then elevate the level of knowledge of what is really going on, break mental models of yourself and people who you do this with. So then you have a better chance of influence this not only system to recreate anticipated behavior. So to sum up, a few things that will make things easier. First of all, you need to have reversed iceberg model. Can you help me? Justyna, can you? I'm missing an arm. Okay, because, well, see. Oh yeah. Because the leverage level goes this way, up. So leverage. So the purpose has the biggest impact on anything else. So one advice could be, and this is what we do in LeSS, what already Jürgen said, make the purpose clear and understood by everybody involved in this change. So set optimization goal, but I mean, don't use this like beautiful high-level words, but think of what elements of the system, how this system should behave. For example, should we be fast, really? Or maybe we should focus more on fast learning, so reduce the cycle time, improve then, based on learning, we would like to adapt. So maybe we could eliminate anything that actually hinders us from changing direction and so on. So the ace of changing direction maybe should goes up. So make the optimization goal clear and set the perfection visual where we are heading and so on. And then you start doing this. So you retrospect or find time and people who you draw the diagrams with. So you elevate the knowledge, level of understanding. So you retrospect, you find next experiment to try, you do the experiment, and you observe anticipated results. And then once again, and then you finally start doing continuous improvement. You challenge the goal, you learn more about how this system should behave, and then you learn about how it works, and then you improve. If you do this, you will finally start gaining the superpower of seeing the whole. Oh, sorry. You may even foresee future changes. You can craft anticipated behavior You will finally switch your thinking from reactive into more strategic, and then you also improve yourself because you will learn from others. You will break your mental models. And well, the last thing I can advise is talk less, do more. Thank you.